Okay, so we're talking rational numbers, because I bet you've seen these. We're going to talk about going from fractions to decimals. First, let's talk about two vocab words. You know what? I'm going to white this out because I feel like you guys focus on just copying instead of the actual concept. So first, write down number one on your scratch paper. Number one is that first vocab word, a terminating decimal, like the Terminator. And then let's talk about it. A terminating decimal, it stops. Decimal that stops and it never repeats again. So terminating decimal, for the definition, let's write down, it's a decimal that stops and it never repeats. And then let's give ourselves some examples. All right, stops, never repeats. I like making up terminating decimals because it's absolutely ridiculous. So we've got examples over here. You can just put them right underneath. Okay, so example of a terminating decimal is 0.895. Check, did it stop? Sure did. 0.895. Did it stop? It sure did. Does it have a pattern? No. All right, I need a hand in the air. Give me another example of a terminating decimal. Make sure it stops and make sure it doesn't repeat. Tyler, thanks for raising your hand. 0.973. Absolutely. Anybody have another one? A terminating decimal? Maddie, thanks for raising your hand. 1.52. Good, terminating decimal. Let's get one more. All right, go ahead. Got it. 1.672. Absolutely. They'll all stop when they don't have a pattern. Okay, so that's terminating decimal. Let's go to our repeating decimal. I feel like it's a little bit obvious. Guess what? Repeating decimals repeat. I know. Crazy, right? So repeating decimals repeat and they have a pattern. Okay. So, examples of repeating decimals. These are also kind of fun to make up. So repeating decimal, I'll start it off. It could be 0.1111, yada, 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 dot, dot, dot. That means it goes on forever. Okay, so you know what? Let's add that to our definition. They repeat, they have a pattern, and they go on forever. They're never ending. I'm going to put that. Thanks, Skylar. And they're never ending. Okay, so if they can never end, can you think of a repeating decimal? Let's get some of your examples. Camille, what do you have?
Well, I was going to say, can't you put a line over it?
Camille said, can we put a line over it? Yes. Okay, so we're going to talk about that in 2 seconds, so you are already way ahead of me. Let's get examples and we'll go to that. Jacob, give us an example.
Well, it would be 2.66.
2.66. Do you want me to do anything else? But it has to keep going, so maybe dot, dot, dot. Okay, let's get another one. Stretch yourselves. Bridger, you got another one? Are you sure? Yeah. Okay, let's get another one. Jackie, got one? Totally, 0.5555. What if I change Jack's and I put 0.545454 dot, dot, dot? Is that a repeating decimal?
Yeah, but you would have to have a line on top of the 5.
Exactly, it's totally repeating. There's a pattern to it. The 5 and the 4 are the repeating. So you guys are like itching to get to the next vocab word. Okay, let me use the magic of the board. Highlight all of this. There you get it. Like that, go back. One more time. So check. So you are ready for the number 3 vocab word. Write it down. Let's write bar notation. You guys kept trying to say, but there's an easier way to write those. Okay, bar notation, you can just put a bar above the number that's repeating. So our first repeating decimal was 0.111111, yada, 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 right? Can I get a hand in the air? So it looks like you guys know bar notation, so tell me about it. Okay, Jamie, tell me about bar notation for this one, 0.1111.
Well, we would just put like 0.1 with a bar over it, which means that it's going to repeat over and over and over.
Perfect. She said put 0.1 but put a bar over it. What do you mean by it? Where does it go?
Over the 1.
Over the 1, so that says just repeat the 1. All right, I need a hand in the air. Tell me about 2.666666. How would I write that with bar notation? Bridger? Perfect. You put a bar above the 6, so that'd be 2.6. Thank you, Bridger. Now, I saw when I was checking other classes' homework, they put 2.66 and put a bar above the 6 and the 6. Is that a little bit unnecessary? I agree. That's a little pretty unnecessary. We only need to know that one of them's repeating. Okay, Brandon, you still with us? Brandon, can I put you on the spot? Can you help us with this one? Do you know how to write 0.545454 with bar notation? What are you thinking? Where would the bar go? Definitely on the 4. Guys, does it need to go on anything else?
Yes.
What else? The 5. So, Brandon, you watching? So that'd be 0.54. Since the pattern is 5, 4, and then 5, 4, and then 5, 4, you would put the bar above both the 5 and the 4. So the reader knows do 5, 4, and then 5, 4, and then 5, 4. Yeah? Guys, how many of you are like, I already got bar notation, I am confident. Okay, fantastic. Let's do one more vocab word. Are you ready? Other than So this is going to be number 4. Let me switch that. So number 4, write rational number. And then I'll listen, erase it. Let's do our own definition. Let's put it in our words. Okay, here we go. A rational number is a number that can be written as a fraction. Again, a rational number is a number that can be written as a fraction. And then I have this awesome graphic organizer of different numbers that are rational numbers. We'll stop and talk about it. Okay, so these are all rational numbers. Rational numbers are every whole number, all the integers, and then some decimals, and then fractions, of course. So I need a hand in the air. I need you to spot stuff in the graphic organizer. I need someone to spot something that's already a fraction. So for crying out loud, we don't need to rewrite it as a fraction because it's already a fraction in there. Can you see it? Raise your hand if you see a fraction that's already in that graphic organizer. KT, what do you see?
3.5.
3.5 is already a fraction. I'm going to put a check mark by it. Check. We know that's rational because rational numbers can be written as fractions. So what's another one I can already check off? What's another one? -2/3. Check. All right, I'm going to change up the colors. Now we've got to talk about the other ones. Can they really be written as fractions?
Yes.
So let's start with the whole numbers. Let's start with the whole number 4. I need a hand in the air. Does anybody know how to change 4 to a fraction without changing the value? So it's got to stay 4. But how do you write it as a fraction to make it stay as 4? Tyler, what are you thinking?
I was thinking you put like where the 3 is on 3.5, you put the 4 there. So like there's 4 on the side, and then you have your 2 numbers.
So 4 on the side and then the 2 numbers? Not quite. He said put it like the 3.5. Now I would change it a little bit. We don't want to change it. We still want a value of 4. So how can we keep the value? Okay, Jillian, what are you thinking? 16 over 4 would definitely be 4. What if I want 4 in the final answer, though? So what if I want 4 in my fraction? I agree with Jillian. 16/4 is definitely 4. Is there another way to do this? Because that would absolutely work, Jillian. What's another way, Josephine? 4.0, that's a decimal. But we want a fraction. 4 over 10, let's think about that. Is 4 over 10 the same as 4? No, keep going though, keep going. You were so close, Josephine. Okay, call on somebody. All right, Jamie, what do you think?
You put the 4 over a 1.
There you go, guys. What do you put it over? A 1. Shout it out. What is 4 divided by 1?
4.
It's 4, so we didn't change it. But like Jillian's, it's the same thing. 16/4 is 4. 4 divided by 1 is 4. All right, here we go. So next, we did 4 over 1. So how would you rewrite 0 as a fraction, guys?
0 over 1.
Yeah, just 0 over 1. So check. Those ones are done. So what do you think about -10? What would you do with that one? You can shout it out. Perfect. What about -2?
-2 over 1.
Okay, the last ones we need to talk about is this 5.8 and this -1.2 repeating. So let me move the board so we have more room to talk about these. We're going to just a second. If it's a decimal 5.8, can I get a hand in the air? Can you tell me how to change 5.8 to a fraction? Vivi, what do you think? Okay, she said since 5 is the whole number, just put 5. Okay. I love that. She said if you say the decimal out loud, it's 8/10. So you put 8/10. Hey, in math, we always simplify our answers. So 8/10. What can 8 and 10 both be divided by? 2. So let's divide both by 2. Put that away right now. Come here, put it away. Oh, divide them both by 2. That's going to be 5 and what? 4/5. Check. We're done. Again, always simplify your answers. Okay, are you ready? So you wanted a story, I'll tell you a story. So when I was a math student, I was your age. I was a really good student, but back then, being a good student was if you were quiet, you were considered a good student. So I was very quiet because I always did my homework in class because I hated homework. I would rather go outside and play. So I made sure that any class, I always did my work immediately. So I did my work, but then I just sat and played with the calculator. So I played with the calculator and I figured stuff out. And it was just like me dorking around on the calculator. I'm not like a genius. I was just playing with stuff and I noticed. So let me show you. We're about to talk about this -1.2. But that 2 has bar notation. So how are we going to write that as a fraction? Let me show you what I learned when I was your age. And it was just like, I just happened on it. I was just playing around and I figured something out. So I was playing with the calculator, being appropriate, not bugging my neighbors. And I typed in 8/9. Well, 8/9, I learned at your age that just meant 8 divided by 9, right? Okay, so you guys aren't allowed to have calculators today because we got to show our work. So, trust me, do you trust me? 8 divided by 9, when you type it in the calculator, it comes out as 0.888 ... So I was just like, cool. I didn't think too much about it, but then I was like, all right, what if I type in 7/9? So 7/9 just means 7 divided by 9. And it was 777. So then I was like, wait a second. So I tried another one. Well, I don't know if that color will show up. So I tried, don't remember what I tried next. Probably something like 5/9. So that just means 5 divided by 9. I need a hand in the air. What do you think my calculator did on this one? Are you noticing something? Okay, Amanda, what do you think it did?
0.55.
It totally did. So I conjectured, I decided, whenever 9 is in the denominator, it makes the numerator repeat. Do you think that's always true?
Yeah.
It is. So can you go backwards? If I told you there was a decimal that was 0.3333333, what would the fraction have been? You can shout out, guys.
3/9.
3/9. Good job. So check it. This one is 0.222222222. So what's the fraction? 2/9. However, that's not our final answer because what do we do with this bad boy -1? Dean, what do you think?
Put the -1 in front of the 2/9.
Perfect. Put the -1 in front of the 2/9. Now you know the trick. 9 always makes that numerator repeat. Do you want to know one more thing that I learned? Real quick. So I took that and that was pretty easy to figure out. So then I was wondering, what about those weird decimals that are like 4/5, how would I get that? So I tried 4/5, and I divided it by 9, but I should have been smarter back then. Because what is 45 divided by 9? Or I was like, oh, that didn't work. Now I'm kind of embarrassed. So then I was like, all right, maybe it has to match. The 4 has to have a 9, and maybe the 5 has to have a 9. So there's 2 numbers on top, 2 numbers on bottom. Guess what happened? Yep. There you go. So if you ever have matching 9s, that always repeats. Thumbs up. Isn't that weird but cool? Just weird, right? Okay, let's move on. So here we go. This is why I only gave you 6 problems for your assignment because you've got to show your work. Will you copy down this, -2 1/4, and let's do the work together so you know exactly what's expected on your assignment tonight. Easy. So we've got 1/4. So 1/4, we know that just means 1 divided by 4. Every fraction is just a division problem in disguise. So 1 divided by 4, that means that 1 is on the inside, and it's getting divided by 4. Okay, am I going too fast? Do you have that on your notes? Okay, let's talk our way through this. I'm going to play with the colors on the board. So right here, guys, can 4 go into 1? No, so we've got to add a decimal here and here. Once we have that decimal, we can add a 0. Okay, think of this as 10. Guys, can 4 go into 10?
Yes.
Yes, we're going to have remainders, right? So how close can we get? Okay, so let's times it by 2. What is 4 times 2?
8.
So bring it down here, so that'll be 10 minus 8. Let's see, 10 minus 8 is just 2, right?
Yeah.
Crap, does 4 go into 2?
No.
We need another 0. So 0, drop down your 0. Nice. Guys, does 4 go into 20?
Five.
How many times?
5.
Check it. So 5 times 4 is 20.
So that's 0.3 because it rounds up, right?
Okay, Tyler said that's 0.3 if it rounds up. Let's just leave it as 0.25 because that's the terminating decimal, right? It stopped. We're good to go. So our final answer is 0.25. What do you think?
Yeah. No.
I heard yes and I heard no. Why are some of you saying no? Janessa, thanks for raising your hand. Oh yeah, we can't forget that -2. That just tags along, right? So -2 right in front. Now we're done. Hooray! Okay, raise your hand if you got that. Did you stay with me? Kind of. Okay, let's do letter B for the kind ofs. Let's make sure you all understand this. So let me move stuff out of the way. So letter B, we start with 5/11ths. So 5/11ths, we are pros. We know that that means 5 divided by 11. So let's see, 5 divided by 11, that means 11's on the outside, 5's on the inside. Because 11 doesn't go into 5, right? So we need a decimal. Josephine, question? I like that. Did you hear Josephine? Her teacher last year said, keep the fraction like this and then turn it clockwise. And that's how you know 11 stays on the outside and 5 goes on the inside. That's brilliant. Thank you for sharing that. Okay, so here we go. Does 11 go into 5?
No.
Nuts. So we've got to add a 0. Does 11 go into 50?
No. 4.
It goes 4 times, right? We can get close. So 4 times 11 is 44. Thanks, Harrison. Subtract it. So 50 minus 44 is 6. Oh, man. All right, Harrison, keep helping me. 11 doesn't go into 6, so what should we do? Add a 0. How many times does it go into 60, Harrison? 5 times. So 5 times 11 is 55. We subtract that. Let's see, 60 minus 55 is 5? All right, wait, but it doesn't go into that. So we add a 0. Drop down to 0. How many times does 11 go into 5? 50. 4 times. It's repeating. Are you sure it won't ever stop? Yeah, you're right, because then we'll get a 6, and then we'll bring down to 0, and then it'll go in 5 times. Don't you think it'll just keep going like that? It'll be the same. So this is a repeating decimal. So that's 0.45. Okay, Brandon, I'm going to come back to you. Where do we put the bar on this one? Which number? Good job, Brandon, on the 4 and 5. Woo! Are you starting to understand why I only gave 6 problems? Because I want to see all this work. Tyler, comment, question? No? Okay, sure.
On the vocab words, do we have to write like what it is?
You'll be okay. She asked, on the vocab words, we have to write what it is. On your assignment, it just says show the work. Go from a fraction to a decimal, decimal to fraction. Talk yourself through it. Okay, we have one more thing to do. Guys, hold up 5 fingers and wiggle them. And then put them close to your eyes. Guys, if you blink, you'll miss it. I think you guys already know how to do this. Don't blink. I'm going to show you how to do this. Tyler, save it. Hold on 1 second. Okay, what if we have to go back? Decimal to a fraction, guess what? I have to admit, I love this. I would much rather go from a decimal to a fraction than a fraction to a decimal. Here's why. Write on your notes. You already know this stuff. You have background knowledge. 0 point, and then put a slash, slash, slash. I bet money you guys already know this. Okay, what's that first spot called after the decimal? Shout it out.
Tens.
Write it underneath that. Tenths. Okay, what's the second spot? Shout it out.
Hundredths.
Hundredths. And what's the third spot? Shout it out.
Thousands.
Thousandths. Okay, there's a couple ways to do this. Now, I learned when I was your age that you just say it out loud. So this decimal up here is negative 26 hundredths. It gives it away. Or you can just look at the last number and say, all right, that last number is in the hundredth spot. So how does that help you? Are you listening? Don't blink. Don't close your ears. So negative 26 hundredths, that means literally negative 26 hundredths. Easy enough? So you take the decimal off and that goes in the numerator. You You figure out what spot it's in, and that goes in the denominator. Easy enough, don't forget your negatives. That's what I noticed when I checked homework, people were forgetting their negatives. However, are we done? No, Camille, is that what you were going to say? We're not quite done, because in math, we always simplify. So, 26, is that even or odd? 100, is that even or odd? They're both even. If they're both even, you can divide by 2. Okay, so let's divide this top one by 2.
26 by 2.
Yep. Hey, shout it out. What is it?
13.
And then what's 100 divided by 2? Are we done?
Yes.
So you're forgetting something I told you everybody else is forgetting. Don't forget the negative.
Yeah. Miss.
Okay, Tyler, you remember?
I was gonna say so if there's like a 8 on top and like 11 on bottom and then negative, and then you're changing it to decimal.
Uh-huh.
How would you write it? Because in the book it shows negative 9/10 and I have it.
Okay, so Tyler's question, let me make sure I understand. Hold your conversations, guys. Tyler's question is, what if you have negative, let me change the color. What if you have negative 8 over 11 and your directions say go from that to a decimal? Honestly, Tyler, I would just do 8 divided by 11 like we practiced. And then I put the negative on the end. And the final answer. Make sure you show your work. Right, question.
Okay, so you know on the 2600,
Mhm.
we did the negative sign on 26 and then the negative sign on 50. Which one would you?
Oh, that's a great question. So Brooke is wondering, how come the negative was on the 26 when we started, and now it's on the 50? Honestly, Brooke, it doesn't matter. It can be one or the other. If I was doing perfect math and I was being like math manners, I would have put it like this. It should be negative out front, and then 26 over 100. The negative should be right in line with the fraction sign. So it's saying this whole fraction is negative. Sloppy mistake. Okay. All right, guys, fantastic. Open your books, page 32. We've got 1 through 6.